Hello friends, so this is question number 21. In the circuit shown in the figure below, all the diodes are identical with V gamma cut-in voltage of 0.6 volt and non-zero forward dynamic resistance at a thermal voltage of 25 millivolt, okay, and take eta equals to 1. Then calculate V out by V in, that means the voltage gain, okay. So this circuit is given, okay. Now you can see in this circuit all the diodes are in on, okay, or are in forward bias, because suppose let us take any of them in reverse bias, okay. Say let us assume this diode is in reverse bias, okay. So you have to open this particular diode, okay. Now see, the 1 milliampere current is coming from here, so it must pass through this diode. So this is 1 milliampere because this is open circuit for this diode. Now let us assume some current is coming from this source, that is I, small I. So what is the total current in this diode? So it is basically 1 milliampere plus I, okay. Now you can see another current source is here, okay. So the value is 1 milliampere, the same value of this particular current source, okay. So the 1 milliampere plus I current is coming and 1 milliampere is leaving, so small I amount of current must go in this path, okay. Then only the KCL will be hold over here, okay, because sum of these two current is basically this current, okay. So this is basically this plus this, okay. Now you can see for this diode it is reverse bias. I mean through this diode this I current cannot flow, okay, in this direction, okay. So that is why this is violating the condition. So all the diodes in this circuit must be on, okay, right. Now in order to find the voltage gain we need the small signal model, okay. You can see the from the DC analysis it has a 0.6 volt, it has 0.6 volt, 0.6 volt, 0.6 volt, okay. So you can find the DC voltage over here, but in order to identify the voltage gain you have to identify the small signal model of each diode and all the for all the elements, okay. Now for the diode we know the diode equation is basically ID is basically IS into e to the power VD by eta VT minus 1, okay. Now you can identify the RD, small signal resistance. RD is basically del ID by del VD whole inverse, okay. So identify the del ID by del VD. What is that? That is basically your IS into derivative of this part, okay. So this is basically e to the power VD divided by eta VT, because the derivative of exponential is exponential, okay, same function, and the derivative of this this part, that is basically your 1 by eta VT, okay. Derivative of 1 is 0. So okay, so this is IS, right? IS, right? Now you can see this IS into e to the power VD by eta VT. You can approximately write this particular portion as a ID, okay, because this IS is very small. So this is approximately IS into e to the power VD by eta VT, okay. So this is basically your ID into 1 by eta VT. So what is the dynamic resistance? RD is the inverse of this del ID by del VD, so it will be eta VT by ID, okay. Now you can calculate the value of RD, okay. Now VT is given, VT is 25 millivolt, and eta is 1, and ID, okay, ID the current through this diodes, okay. So this ID will come from the DC analysis, okay, from the DC analysis. So for DC analysis we can remove this source, because this small signal source you can remove by the equivalent circuit. So you can replace it by a short circuit because it's a voltage source, okay. This is a ground already, and these are plus minus 0.6 volt, plus minus 0.6, plus minus 0.6, plus minus 0.6, okay. So you can also replace them by a voltage source of magnitude of 0.6 volt, okay. Now you have to find the current through the diodes, okay, so that you can identify, you can measure the value of RD. Okay, now you can see what is the potential over here. It is 0 because it is ground. Okay, now with respect to this point, what is the potential over here? This is 0.6. You can see here is negative, here is positive, it is 0.6. Okay, now this 0.6 with a negative sign, minus 0.6. Okay, now you can see here is another voltage. Okay, minus 0.6 plus 0.6, that is 0. So what is the potential over here? It is 0. This is 0, this is 0. Okay, so what is the current through this 50 ohm? It is 0 because the potential voltage drop across this 50 ohms is 0. So you can see that this particular current 1 milliampere will exactly divide into the two part with 0.5 milliampere to each path, because they are symmetrical path. Okay, so what are the currents? It will be 0.5 milliampere and 0.5 milliampere. Okay, so here also it is 0.5 milliampere, it is 0.5 milliampere. No current is flowing through this 500 ohms resistor. Okay, so the value of ID is 0.5 milliampere. So the RD for all the diode, the RD is same. So it is 1 into 25 milliampere divided by 0.5 25 millivolt divided by 0.5 milliampere. So how much it is? It is basically your 50 ohms. Okay, 50 ohms. So this is basically the small signal resistance of the diodes. Okay, now you can draw the small signal model. Okay, so for small signal model you have to replace all the diodes with a small signal resistance. Okay, the first thing, you have to replace all the diodes with a small signal resistance of 50 ohms. Then you have to include the small signal voltage Vi. Okay, then you have to replace this sources, independent sources, with this equivalent model, that is open circuit. For this current sources it will be open circuit. This is open. Okay, so this is your circuit. Okay, so you have the 50 ohm resistors, 50 all are 50. Okay, now you have to calculate this particular voltage. Okay, it is no longer 0 volt because we are right now analyzing the circuit with respect to small signal model. Okay, so this is plus minus V out and this is V in. Okay, so what is the equivalent value of this? This is 50 plus 50, 100. So 100 and 100 parallel, so it is basically 50. Okay, so this is 500. So the circuit basically your Vi, V in is a 50 ohm in series with 500 ohm. Okay, and this is the output. So plus minus V out. So V out by V in is basically 500 divided by 500 plus 50, 550. Okay, this is 5 tens are 50 and 5, so 10 by 11. So voltage gain is basically here 10 by 11, that is your 0.909. So this is 10 by 11, that is basically 0.909. Okay.